We're now going to look at the intersection of a line and a circle. So if we think about the situation, if we've got a circle, then if we have a line that might intersect with it, there's three possibilities. So one is that the line is going to intersect the circle at two distinct points. So here and here, for example. So that would be example A. Example B is that it could be a tangent to the circle. So that means it would touch it at one point only. And example C is that it would miss the circle entirely. And when we're trying to solve these, what we would generally end up with is a quadratic equation. So in this example below, 104, we've got a straight line with this equation, and this is the circle. And we'll be creating an equation by substituting in for the y value by replacing it by the x minus 5. And then it would turn into a quadratic equation. And by looking at the discriminant, we could decide whether it was going to have 2 points of intersection, one or none. So if we think about the actual discriminant itself, that's the b squared minus 4ac. And so the bit underneath the square root of the quadratic formula. And if it's greater than 0, then that would be situation A. So greater than 0 would mean we had two solutions to our quadratic, which corresponds to having 2 points of intersection with a circle. Situation B would be when b squared minus 4ac is equal to 0. And that would correspond to it being a tangent and only having 1 point of contact. And situation C would be when the discriminant was actually less than 0. And that would mean there were no solutions to the quadratic, which would correspond to there being no places where the line would touch the circle. So that's how we can know by looking at the discriminant. So I'm going to look at this example now. So determine the coordinates of the point of intersection of this straight line and this circle. So we've got a simultaneous equation here, and one of the equations is a linear one and one of them is a non-linear one. And we're going to substitute in the y equals x minus 5 into the non-linear equation. So if we do that, then what we'll get is this x minus 1 squared plus, and now replace the y by x minus 5, then plus 2 squared, and then that equals 4. So if we tidy that up a bit, so I'm just going to simplify the second bracket. We're going to get x minus 3 all squared equals 4. And so what I'm going to need to do is multiply out these brackets and create a quadratic equation, so in the standard format. So if I do that, I get x squared minus 2x plus 1 from squaring out the first bracket. If I square out the second bracket, I'll get x squared minus 6x plus 9. That's still equal to 4. So if I then collect up terms, I'm going to get 2x squared, I'm going to get minus 8x, and I'm going to get plus 10 equals 4. Now I'm going to take the 4 over the other side to make it equal to 0. So I'll get 2x squared minus 8x plus 6 equals 0. And then it's just easy to divide through by 2 at this point to simplify the quadratic. So I'll get x squared minus 4x plus 3 equals 0. And then you can solve that on the calculator or factorize it. So and we'll just factorise it at the moment. And so we've got x, and then we're going to have -3 and -1. So the solutions that will give me are that x is equal to 3, and the other solution is that x is equal to 1. But because we're after the coordinates for each one of these values, we need to find the y value as well. So we've got the coordinate, the x and the y. So we can do that by just taking our linear equation here and substituting in the value of x. So for x equals 3, we'll get that y is 3 minus 5, which means that y is equal to -2. And for x is 1, we're going to get y is equal to 1 minus 5, which means that y is equal to -4. And we'd want to express those as coordinates. So we want to express that as 3 minus 2 for the first one. And we want to express it as 1 minus 4 for the second one. So this is 2 points of intersection. And I'm going to now also look at the discriminant, and let's have a look and see what that would do. So looking at the discriminant, we've got our equation, which was x squared minus 4x plus 3, after we'd substituted in the y equals x minus 5 and simplified the quadratic. So we know in this case, if we look at the a is the value in front of the x squared, so a is equal to 1. We've got b is equal to the value in front of the coefficient in front of the x, which is -4. And we've got that c is the 3. So c is equal to 3. So if we substitute those into the discriminant, which is b squared minus 4ac, then what that will give us is that we've got b squared, so -4 squared minus 4 times 1, which is a value, times 3, and that is equal to 16 minus 12, which is 4. And we know that 4 is greater than 0. So that would mean 2 solutions, which is actually what we got, because if we remember, the 2 solutions we got were 1 minus 4 and 3 minus 2. So those were our points of intersection. So we had got this situation where the line crossed the circle and therefore intersected it at 2 points. I'm now going to look at a more of an exam style question. So again, this is to do with the intersection of a straight line and a circle. So we've got a circle with this equation, x squared plus y squared minus 4x minus 14 equals 0, and we've got to find the coordinates of the center of the circle. So the first thing that we need to do is use the completing the square method to try and get this into a standard form of our circle equation. So I'm just going to do that by rearranging the order of this equation. So we collect up the x parts together. So we've got this, we've got x squared minus 4x plus the y squared minus 14 equals 0. So if I try the completed square on this first part here, x squared minus 4x, and what I'm going to do is I'm going to have an x, and then with minus the half of the coefficient of the x term here. So for half it, I get -2. So x minus 2 in the bracket, all squared, and then I'm going to take away this coefficient halved and squared. So in other words, it's going to be, put this in a bracket at the moment, so minus 4 over 2 all squared. So this is, I'm just looking at this part at the moment. So that's going to equal x minus 2 all squared. And then if I divide the minus 4 by 2, I get minus 2. If I square it, I get 4. And then, so I'm taking that away. So that's our x squared minus 4x written in completed square form. So then I've still got the plus y squared minus 14 equals 0. And what I'm going to need to do is get the number part, so the minus 4 and the minus 14 over the other side. So that will mean that it will look like this. X minus 2 squared plus y squared, and then that's equal to 18. I'll take that over the other side. So now it's in the correct format, I can now decide what the coordinates of the centre of the circle are. So because our standard equation is x minus a squared plus y minus b squared equals r squared, then we can see that the coordinate is going to be a comma b is the coordinate of the centre of the circle. So we can see that in our case, a is equal to 2. So that's the x coordinate of the centre of the circle. And because y isn't in a bracket at all, that's the equivalent of b being 0. So the coordinate of the centre of the circle is 2, 0. And so that's part 1, A1. And then A2 is asking us to find the radius of the circle in the form p root 2. So the radius is equal to the square root of the 18 here, because the 18 is r squared when it's set up in this format. So that's root 18. And I can deal with it in the manner of dealing with surds. So I'm looking for a square number that I can take out. So I can see that I can factorize it as being root 9 root 2, and the 9 being the square number, and then obviously the square root of 9 is 3, so it's 3 root 2. And so we've done it because p is equal to 3. So that's the first part, part A, completed. If we now look at part B, what we've got is a line has an equation y equals 2x minus x, 2k minus x, and k is a constant. So that means k is a number. And show that the coordinates of any point, the x coordinates of any point of intersection of the circle and the line satisfy this equation. So what we've got is a simultaneous equation between y is 2k minus x and also the equation of the circle, the x squared plus y squared minus 4x minus 14. And so we're going to substitute in the linear equation into the non-linear equation. So I'm going to replace the y in the circle equation by 2k minus x. So if I do that, what I get is x squared and then plus, and I'm going to put this in a bracket, 2k minus x all squared minus 4x minus 14 equals 0. So I'm going to need to square out this bracket. So what I've got is x squared, and then if I square out the bracket, I'm going to get 4k squared minus 4kx, and then plus x squared, and then the minus 4x minus 14 that we had previously. And that's still equal to 0. So I'm now just going to collect up terms. So I've got 2x squared there. I'm also going to look to collect up terms in the x. So this is a quadratic, obviously. We've got x squared, we've got x's, and then just numbers. So if I'll just write them next to each other for now. So we've got minus 4k x and also minus 4x. And then we've got plus 4k squared, which is just a number. And then minus 14 equals 0. So I'm going to tidy this up a little bit. I'm going to factorize the 4k x and the 4x. So I've got 2x squared minus, and I can take out a 4x there. So 4x, and then I'm going to have k plus 1. So it's starting to look a little bit like what I'm trying to get to. And then we've got 4k squared minus 14 equals 0. The easiest thing probably to do at the moment is just divide through by 2. And in fact, that will give us what we're looking for there in part 2. Sorry, in part 1. There we go, part 1, this one. So we're going to get x squared minus, I'll just rearrange the order of this one. So divided by 2, I'm going to have 2k plus 1 x, and then plus 2k squared minus 7. So that's as required in part 1, in B1. So we've now, in part 2, got to find the values of k for which this equation has equal roots. So equal roots means it only has one solution. So this would be the case where there's actually a tangent to the circle. And so for one root, which is also called equal roots, then we need to look at the discriminant again. So we're going to look at the discriminant. And the discriminant is, as we know, b squared minus 4ac. And for us to have equal roots, then that must be equal to 0. So in our case, b is this minus 2k plus 1. So I'm just going to substitute everything into here. We can see that a is actually 1, and c is the 2k squared minus 7. So I'll just write these here just for clarity. So a is equal to 1, b is equal to minus 2k plus 1, the coefficient of the x, and then c is the number, which this is a number even though it's in terms of k. K is a constant, so we may need to work out the value of k later on in the question. Would be the usual thing. So so that's c is 2k squared minus 7. So what we're going to do then is substitute them into this discriminant and create an equation. So we'll get b squared, so we'll get minus 2k plus 1 all squared, and then minus 4 times 1 times by 2k squared minus 7, and that's all equal to 0. So, and in fact what we are doing is we are looking for the values of k. So we are looking for the numerical value of k here. So if I square this out, what I'm going to get is 4k plus 1 all squared minus, and then this is going to be 4 times 2 minus 4 times 2k squared, which is going to be 8k squared, and then it's going to be minus 4 times minus 7, which is going to be plus 28. That's still equal to 0. So I'm going to need to then square out this bracket. So I've got 4, it's going to be k squared plus 2k plus 1, with all the rest of the stuff added at the end. Multiply out the bracket. Then collect up terms, so we get minus 4k squared. The easiest thing now really is to divide through by minus 4, so I'll get a positive coefficient of plus 1 for the k squared, and that will give us k squared minus 2k minus 8 equals 0, and we can solve that just on the calculator, or we can factorize it. So that will give us k at the start of each bracket, and then we would have minus 4 and plus 2, and then solving each one of those two brackets, that would give us the values of k would be k is equal to 4, or also k is equal to minus 2. So next thing we need to do is we're looking at part 3, and we've got to describe the geometrical relationship between the line and the circle when k takes either one of these values. So we're trying to see what actually does this mean? What's the maths actually showing us? So that's the next thing that we're going to look at. So we can see the circle as I've drawn it there, and as we calculated before, the centre of the circle was 2, 0, and we also knew that the radius of it was equal to root 18, which is just over 4, so just a bit more than 4. So it would look like that. And we've got this line y equals 2k minus x. So we've got two options for it. The first one is that y, where k is 4, if we multiply the 2k by 4, then it's 8 minus x. And the other option is, with k being minus 2, is that y would be minus 4 minus x. So if we try and sketch these on here, then that would be a line which would go through the first one. It would cross the y-axis at 8, and it would look something like this, touching the circle once above. So that's only one solution, as we were finding, and that would be a tangent. And the other solution is where it crosses at minus 4. So we would say minus 4 would be roughly here, we'll say, and that would touch the circle once just below it. So that's what our solutions mean. It's saying that we've got a line touching the circle either above once as a tangent or below as a tangent. So if we describe the geometrical relationship between the line and the circle when k takes either as values, the line is a tangent. and it's touching either above or below the circle. Or below. And that's it.